Hello dear students, welcome back with another video of the series evaluation of double integrals. In previous two videos I was talking about the evaluation of double integrals when the limits of integration are all constant numbers, and in another video I talked about the evaluation of double integrals when two of the limits are constant numbers and the other two are of the function of x. In this video I'm going to talk about another type of double integral where we want to integrate the function f of x comma y with respect to x first, where the limits of integration of x are x is equals to h1 y and x is equals to h2 y. Then with respect to y, where the limits of integration of with respect to y are the constant numbers, so we are writing c to d, means that this is the value of let's say y is equals to c to y is equals to d, right? So when we are integrating with respect to x, here are the limits of integration, which are the values of x in terms of y. So x is basically the function of y, h1y some function of y, here h2y is also some function of y. So we'll integrate this function f of xy with respect to x, applying limits of integration. The result of this first integration would be the function in variable y. Then we'll integrate with respect to y, applying these constant limit of integration. The final answer would be a constant number, so that is fine with the order of integration, that is fine with these limits of integration. Let's take an example and try to understand it further. For example, we want to integrate the function xy with respect to, let's say, x from x is equals to y to x is equals to 1, then with respect to y from y is equals to 0 to y is equals to 1, right? Now here you can consider this 1 as the function of y, right? You can always write 1 into y power 0, so that would be 1, and this is written as x is equals to y, so that is in the form of this type of integral, where the first integral limits of integration are function of y and the other are the constant limit of integrations. So let's begin solving it. Integration of xy with respect to x would be x square over 2 times y, right? Taking the limits of integration, x is equals to y to x is equals to 1, and then integration with respect to y, where the limits of integration with respect to y are y is equals to 0 to y is equals to 1. Now applying the limits of integration, that would be value of x is equals to 1, so that would be 1 square divided by 2 times y minus x is equals to y, so that should be y square divided by 2 times y. Then integration with respect to y, where the limits of integration are y is equals to 0 to y is equals to 1. Simplifying this, that would be equals to this should be y minus this should be y cubed divided by 2. Now we want to integrate it with respect to y, with the limits of integration are y is equals to 0 to y is equals to 1. Integration of y minus y cube over 2 with respect to y is y square divided by 2 minus y power 4 divided by 2 times 4, that would be 8. Taking the limits of integration, which is y is equals to 0 to y is equals to 1, applying the limits of integration, we can write y is equals to 1 here, so that would be 1 square divided by 2 minus 1 power 4 divided by 8. Then applying limits of integration, y is equals to 0, so that would be 0 square divided by 2 plus 0 power 4 divided by 8, so no need to write 0. Simplifying this, that would be equals to 1 upon 2 minus 1 upon 8, and when we simplify it, that would be equals to 4 minus 1, that would be 3 over 8. That is the answer. That is the answer of the integration of the function xy with respect to x from x equals to y to x equals to 1, and then with respect to y from y equals to 0 to y equals to 1. So this is how we solve this type of double integrals. As I mentioned in the previous example as well, you cannot have this order of integration as dy and then dx. You cannot integrate this function where the limits of integration of the first integral is the value of x in terms of y. You cannot integrate it with respect to y first, because if you are going to integrate with respect to y, we should have the limits of integration of y variable, but here we are given x variable. So integration with respect to x variable of variable values should be of x is equals to some function of y, and then we will integrate with respect to y, and the other limits of integration should be constant numbers. So this is how we solve this type of double integrals. I hope that this video will be useful for you. If you have any questions, queries, or if you want me to solve any problem, a specific problem where you feel any difficulty, just write them, just mention them in the comment section. I'll be trying my best to solve your queries. Thank you very much.